In this session on single dimensional arrays, I am going to talk about how you can enter numbers into an array and see whether a search number exists or not. So let us say first I declare an array with a capacity to hold 50 numbers. I have been using I to travel or use it as an index through the array. Now, I want to know not only whether the search number exists or not, I also want to know the position of the search number. Then followed by that, I want n, which tells me how many numbers the user is actually going to enter. Although the capacity is 50, the user may enter only 5 or 7 or 10 numbers. And ELE stands for the search number the user is going to enter. So let's say first I ask the user how many numbers he or she wants to enter. Let us say the user says they want to enter 5 numbers. Then using this loop, I am going to read 5 numbers. Let us assume the 5 numbers are 23, minus 9, 7, 0 and 36 stored at these particular locations in the array. Now what I am going to do is, let us say I want to search whether 7 exists in this array or not. So I am asking the user enter the search location, enter the search value. So the element I want to search is whether 7 exists or not. In addition to that, I am also interested what is the position of 7. The position of 7 is 0, 1, 2. But we are counting from 0, but normal people count from 1. So whatever is the position, we are going to add 1 to that position. So we are going to say 7 is at position 3 because people don't understand that we can count from 0. So what I do is, initially it is also possible that the number I am searching may not exist in this particular array. That is why what I have done is I have made this position element as -1. So this will remain -1 if the search number is not found. Now it's quite a simple program. I'm just going to loop through and compare each number. So take a look here. Starting from I is equal to 0. 0 is less than 5. Now element is 7. Is 7 equal to a of 0 is 23 is false. I is increased to 1. Then element is again 7. A of 1 is -9. Is -9 equal to 7? It is again false. So it will go. I becomes 2. Now 2 is still less than 5. A of 2 happens to be 7. Element is 7. So is 7 equal to A of 2? This is perfect. This condition is true. So what happens is position is equal to value of I. What is the value of I? Value of I is 2. Then I need to break because I have found the search element. Then what do I do is, if the position is greater than or equal to 0, it indicates that the element exists in this search array and I can print the position as position plus 1. So it will say in the third location, that is 1, 2 and 3, that 7 is found. Else I am going to say it is not present if position retains the original value of -1. So this is a simple problem. How do you go about finding whether a search number or an element exists in an array? There's one more possibility to it. Let us say I am searching for the number 99. What will happen is, it will go through this loop. It will check each element with 99. Since 99 does not exist, it will say it will finish off the loop. The value of position will remain -1. This will be false. It will say element 99 not present, and then it will end the program. So this should give you an idea about how we go about searching for a value in a single dimensional array. I would suggest you take a little more numbers, maybe take 7 or 8 numbers, run through with different test cases by drawing a table. Do in one case where the number exists, do in another case where the search element does not exist. So to get a better understanding of the logic, I have used the break because the minute the number is found, no point in continuing to search. All right. Now let's look at how an array is represented in main memory. Let us say I declare an array of characters A of 5. So we all are aware or by now you should be aware, array of characters occupies 1 byte or 1 byte per character. So let us say the array is started storing from address 5000. So a of 0 will exist at 5000, a of 1 will exist at 5001, a of 2 will exist at 5002, a of 3 will exist at 5003, and a of 4 will exist at 5004. So this means since it occupies 1 byte, each position can be found at the corresponding address this way. So subscript A of 0 will give you the content of address 5000. Subscript A of 3 will give you the content of address 5003. Now let us come to example of declaring an int with capacity only 3. We all are aware integers occupy anywhere between 2 to 4 bytes depending on the machine. On most of the machine it happens to be 4 bytes. But let us assume in our example machine each integer occupies 2 bytes. Since each integer occupies 2 bytes, in the address 5000 and 5001, the zeroth element is going to be stored. 5002 and 5003, the first element. 5004 and 5005, the second element. Now why two addresses per element of an integer? Because an integer occupies 2 bytes. So for character it occupied only 1 byte, so at each subscript it was mapped directly with one address. But here integer occupies 2 bytes, so a of 0 is present at 5000 and 5001. A of 1 is present starting at 5002 ending at 5003, so on up to A of 2. Now you can calculate the total size of the array like this. Size of the data type. What is the size of character? Character occupies 1 byte. What is size of the array? 5. So 1 into 5 is equal to size of this particular character array. Now in my case I am assuming int occupies 2 bytes. So 2 into 3 numbers, it's going to be 6 bytes. So character array occupies 1 into number of, or the maximum number of characters in the array, and integer array 2 is the, we are assuming 2 is the size per int multiplied by the number of elements 1, 2 and 3. So 2 into 3 is equal to 6 bytes. So with this I hope you have understood a concept where I have shown you how you can search a number in an array, as well as how one dimensional arrays are represented in main memory. So this concept is valuable to understand, because when you are learning something called pointers in the next year, this is going to be of lot of help.